Savart law. So first of all, in electrostatic, we know that electric field is directly proportional to charge and inversely proportional to the distance between these two charge. Okay. Basically, electric field is given by what?
KQ by R square.
K Q1 Q2 by R square or
Q1.
K?
So that's F, isn't it?
Only one charge.
Yes,
Okay.
sir.
So always remember this. So here, electric field is responsible. A charge is responsible for the electric field. Okay. Here electric field linearly depends on the charge and inversely depends on the square of the distance between the charges, right? Or the distance from which we are measuring the electric field. So same way in magnetostatics, if we talk about a wire, let's say this is the wire, okay? And let's take one element over here having the length dl. So we know the current is flowing in this wire, okay, also passes through this element, right? So if we want to find out the magnetic field at this point P from this element, okay, because we know current carrying conductor can produce magnetic field, right? So at the r distance, let's take a point B and find out the magnetic field at this point. So according to the Biot-Savart's law, the magnitude of the magnetic field, let's say here the magnetic field is very small, dB. So the according to Biot-Savart law, magnetic field is directly proportional to the current element, okay, dl into I. In electrostatic, we are getting electric field due to a charge, right? Charge was the source of electric field. So in the same way, in magnetic field, this current and element dl and this current I, this product idl is responsible for the magnetic field, okay? Yes or no? And magnetic field is also inversely proportional to the distance between them, okay?
Yes, sir.
So if we want to write this magnetic field in vector form, we can write it as idl cross r upon r cube, okay? We will get this expression. This expression is what? Idl upon r square. We'll get back to this, okay? First,
Yes.
understood that magnetic field is directly proportional to this ideal cross the distance, okay? Remember, this is the perpendicular distance, okay? That's why there is this cross product, okay? And if you remove this proportionality sign, we will get a constant which is mu 0 upon 4 pi into ideal cross r upon r cube. This is the constant. Like in electrostatic, we were getting this k constant. Here in magnetic field, we are getting this mu 0 upon 4 pi. And the value of mu 0 upon 4 pi is simply 10 raised to minus 7. Or mu 0 can be given by 4 pi into 10 raised to minus 7. Okay. So the magnitude of this magnetic field, if we want to find out, so it will be mu 0 upon 4 pi. Since here it is the cross product, we can write it as idl r sine theta, right? Because there is this cross product upon r cube. Now we are talking about the magnitude, then this r will get cancelled out and we will finally get this expression mu 0 upon 4 pi idl upon r square. This is the magnitude of magnetic field. See, here we have already discussed it.
So one question. If we want to find B, so we have to integrate if we just want to get P.
Yes, yes, of course. Okay, so this is the formula for the magnetic field from the Biot-Savart law, also called Biot-Savart law. Okay, here what is mu? We just wrote it that mu is equal to 4 pi into 10 raised to minus 7. But what it is called? Mu naught is called permeability. Okay, permeability
Yes, sir.
of free space. Okay, now direction of magnetic field. What would be the direction of magnetic field? So in this case, the current element is this way, right? Yes or no? And the radius
Yes, sir.
or the distance is this way, right? So
Mm.
from this formula, here it is dl cross r. dl cross
So,
r means this is dl,
I,
this is r. So if you use the screw rule
mm,
from dl to r, you will notice that screw will go into the page, right?
yes, sir.
So the magnetic field would be into the page, okay? And if this point was, let's say, this left hand side, the magnetic field would be in outward direction, okay? Okay, so
Sir, uh, this we get it only from the direction of DL and R cross R, not from I.
mm, sorry, yes, it is
The
current element,
direction
right?
of
It is current element, ideal.
not only DL and R, not I.
It is ideal, okay? We write it I with dl. Okay, this is the source of magnetic field. I've already written this.
Yes,
Always
sir.
write with, I mean, always write current with dl, okay? In the case when you are finding the
Okay, sir.
magnetic field. Now, let's discuss similarities between Biot-Savart law and Coulomb's law. Similarity between Biot-Savart law and Coulomb's law. So first similarity is this, that both will depend inversely on the square of the distance, okay? Right? Both are long range force. Both are long range force. Second similarity is that the principle of superposition is applied. Principle of superposition is applied in both the field. Remember principle of superposition, like there are two fields at this point, E1 and E2. We just add, if you want to find the total electric field, we just add them, right? This is the principle of superposition. So likewise, at any point, let's say there are two fields, we can simply add them, okay? So this is the principle of superposition. Okay, next point. This point is very important. This says that magnetic field is linear inside the source. Ideal. Magnetic field depends linearly on this ideal thing, okay? This is the source in case of magnetostatic, or you can say magnetic field. Source of magnetic field. Okay, not just current. Ideal is the source of magnetic field, but in electrostatic, charge q is the source of electric field. Okay, now comes the fourth part, which says that magnetic field is produced by a scalar source. Source is scalar, right? Or vector. It is a vector quantity,
Yes.
but
Sorry, vector.
here the charge is scalar. So electric field is produced by a scalar quantity, while the magnetic field is produced by a vector quantity. Okay, and you can see there is this angle dependence. Here magnetic field depends on this angle. So magnetic field is angle dependence. Okay, while the electric field does not depend on any angle. Okay, so these are the
Yes, sir.
similarities between Biot-Savart law and Coulomb's. So right now we are discussing magnetic field on the axis of a circular ring. So first of all, what we are going to do is that this ring is having radius r. Okay, now let's call this point P. So we are going to assume a small current element. Okay, let's say here it is the small current element whose length is dl and I current is flowing through the this circular ring. Okay, so due to this current element at point P there must be some magnetic field, right? Yes or no? Hello.
Yes.
Okay,
Yes, sir.
so there is this magnetic field, let's say B. Okay, so
Uh,
if this angle is theta, we can also take this angle as theta, right? So it will be B cos theta,
yes, sir.
this will be B sin theta. So
Nine.
similarly, if we take here a current element, we will get magnetic field in this direction, right? And it will have B cos theta in this direction and B sin theta in this
We
direction.
have done that.
So these two will get cancelled out, okay, after all.
Mm.
So if you take any element anywhere, the sign component will get cancelled out, okay? There will be always two pair that will cancel out its sign components, okay? So let's just discuss this one component only, okay? Because sign component is anyway going to cancel out. So we are getting this B cos theta magnetic field over here. Now let's assume that the point P is at the distance x from this ring. So this distance will become what? X square plus r
Square
square.
plus x square.
Okay. Now in this triangle, can you see a right angle triangle?
Yes, sir.
If we want to write the cos theta, how we are going to write it? Adjacent upon hypotenuse.
X by root of x square plus r square.
It will be x upon under root x square plus r. Why we are writing this? Because we are going to need it in later steps. Okay. Now we are basically finding the magnetic field, right? So according to Biot-Savart law, magnetic field is given by mu naught upon 4 pi I
4 by
dl
I
cross r
cross
upon r
r.
cube. This is the vector form, okay? But we are going to reduce it. Okay, we are going to take its magnitude. Okay, so it will simply become mu 0 I dl upon 4 pi r cube r square. Okay. Okay. Now at this point P, what is the distance r? This is the r distance, right?
Yes, sir.
So this is r, but here it is r square. So it will become mu 0 I dl upon 4 pi
Ideal by 4 by
x
2
square
x square
plus r
plus r
square.
square.
Okay. Second reason. But now we need to integrate this, right? This is dB.
Yes, sir.
Okay, this is dB. But since we are getting only this component, sin theta will get cancel out anyway. So if we want to write the full magnetic field at this point, it will be integration dB cos theta, right?
Yes, sir.
Now integration, what is dB? Here is the dB.
Mu naught ideal divided by 4 pi into x square plus r square.
And what was the cos theta that we have found out? X upon under root x square plus r square.
X by, yeah, x by root of x square plus r square.
So it will become integration mu naught I dl into x upon 4 pi x square plus r square
Square plus r, x square plus r square to the power 1 3 by 2.
3 by 2. Yes or
So
no?
we remove mu naught I x divided by 4 pi into x square plus r square to the power 3 by 2.
Taking the constant terms outside of the integration, it will be simply dl. And what is dl? It is the perimeter of this circle, right? Circumference of the circle.
Yes, sir,
So it will be what? 0 to 2 pi r.
0 pi r.
And what is the integration of dl? It is simply L, right?
So you'll get 2 pi r. Yes, sir, 2
Yes,
pi r.
yes, of course. 2 pi r.
R. Okay.
Now, 2, this pi will get cancelled out. 2 2s are 4. Okay. So, we will get mu naught I x r upon 2 x square plus r square raised to 3 by 2. That is what we are getting.
Okay, sir.
Now, if the distance was equal to r, that means if this distance was equal to r, then the expression would become mu naught I r square upon 2. It will be x square plus r square raised to 3 by 2, right?
Yes, sir.
And now, what if the distance x was way more greater than radius? Then we can simply just ignore this x square term, right?
Correct, but then your freaking x is very great, right?
Yes, yes. Sorry.
It's not supposed to be less than r.
Oh, sorry. If the x is way less than r, then we can ignore it. So finally we will get r cube, right? Because these two will get cancelled out.
Yes.
And
So
again
we'll
r
get
will get
mu v is
cancelled
equal
out.
to mu naught I by 2 r square.
No, r square was there, right?
Yes, sir, r square I told.
So the
Sorry, mu
magnetic
naught by 2
field
r.
at the center of ring, magnetic field at the center of ring is given by mu naught I upon 2